replace them, okay? Removal of senescent blood cells. When your cells, your white blood cells or your red blood cells are no longer functional, they're gonna go through what? Apoptosis too. Especially your white ones. The red ones just get chopped up in the liver and split your liver.
So like in celiac disease, is that what it is? Did they say
No, celiac disease is gonna be, celiac is the one that you're sensitive to gluten. So that's gonna be an inflammatory response. That's what you don't want. In fact, the problem with really bad celiacs is you can get inflammatory bowel disease, which is the problem you don't want. So those cells are becoming necrotic.
So it's not, but it's still cell death.
Cell death, necrosis and apoptosis are both cell death, two different mechanisms. One causes inflammation, the other one,
Kills itself.
it's just like recycling. It is recycling. I mean, the body's green. You recycle. All right, so I'll show you right here. Necrosis refers to cell death in an organ or tissue that is still part of a living person who wasn't supposed to die, okay? You're still alive. Often interferes with what? Cell replacement and tissue regeneration, because you have a massive what going on?
Inflammation.
Inflammation, that's gonna interfere with the healing process. It can. That's why some people, especially people like diabetics, what happens to their stores is done. They have poor perfusion, and now you've got an inflammatory response, and the whole thing just becomes a cascade, right? You get that inflammation, and we're talking about gangrene. Gangrene occurs when a considerable mass of tissue undergoes necrosis, and you start getting a massive inflammatory response, and you start killing off all the tissue. There's 3 different types of necrosis we'll talk about.
So the inflammation is the problem.
It's an out of control inflammatory response you don't want.
Hold on.
Anytime it's just weird. Your body reacts to an immune response anytime you dump cellular contents into the environment. You wouldn't think it would because it's still self, right?
Yeah.
But it still does. It sees that as a damage. All right, so right here are going to be intrinsic and extrinsic. Remember I talked about the apoptotic pathways?
Mm-hmm.
In the extrinsic, don't memorize all, guys, don't memorize this, don't. It's the whole pathway. I just thought I would show you how it works, why it's called programmed cell death, okay? So here you got LPS, macro, micro. Where do you find LPS?
Isn't it in bacteria?
Which one?
The negative one?
Gram negative,
Gram
cell
negative.
wall, good. IL-1, FSCs are death ligands here. So they're going to bind to it's even called the death receptor mediated pathway. They bind this receptor, it's going to trigger the death domain, which is FAD, which is going to turn on caspase 9, which is going to turn on caspase 7, which is going to what? Cleave into that, and it's going to lead to apoptosis. But it's a pathway you go through. Okay? Intrinsic mitochondrial mediated pathway, you get that ROS damage to your mitochondria. You want to go through necrosis inside of your cell? No, you don't want your mitochondria spelling out, so what happens? Low ATP levels, what do we trigger?
P53.
P53. Mitochondria is going to go, cytochrome C gets released. As soon as cytochrome C gets released, that triggers caspase 9 release. Again, do not memorize this for the test. If you want to for fun, go ahead. There's about 10 steps that aren't even there. So gangrene is term is applied to the considerable mass of tissue undergoing necrosis. When do you get gangrene?
But
Yeah, too much cell death.
when it's
So
just
it's
like
not is that a
bacteria,
bacteria?
yeah, isn't it?
That's the difference. Can you tell me the different types of gangrene without looking ahead?
Green.
Dry, wet, and
You all look ahead. We'll talk about the difference.
No, you don't talk about it, micro. You think gas is the worst?
Yeah.
And they're different ones. The gangrene is just a general term for what?
Bacteria.
No,
A lot.
considerable mass of
Necrosis.
tissue undergoing necrosis. So
So
that's
it's
what
not a
gangrene.
bacteria.
It can be.
Yeah.
It can be anything. It could be anything that causes it. Dry gangrene affects tissue. Tissue becomes dry and shrinks. The skin wrinkles, color change to dark brown or black, and the spread of dry gangrene is slow. So this is just usually due to a loss of perfusion, right? Cells start dying and they start kind of slowly pulling back. Blood flow's impaired, and this is where you get what?
Diabetes.
Diabetes with gangrene. You hear about diabetes associated with gangrene. So you get vascular disease and you get autoimmune response.
So it's basically like an inability to recover the tissue.
Well, the main part with diabetes is what causes it, not the diabetes itself.
It's
right?
the circulation, the blood
The
flow.
vascular damage. So you get low perfusion, you don't get enough oxygen, you don't get enough nutrients. You also impair the immune response to some extent. That's why it can't heal, and you get the dry gangrene.
And that's because of all the.
Yeah, the glucose in it causes a lot of vascular damage. It also causes what other damage? What's the other damage from long-term uncontrolled hyperglucose? Kidney damage too, some of it's nerves, and they also get peripheral nerve damage from it. And I'm thinking about more diabetes. And we'll cover some of that later on. Wet gangrene is infection usually, but also what?
Trauma.
Trauma, burn, anything, just you lose that blood supply, right? The infected area is cold because why is it cold?
No more
There's no
blood flow.
perfusion?
You've got no perfusion, you have no blood supply, so it's gonna be cold, black, and under tension. Why is it under tension? This is a nasty one. You get a buildup of fluid in there, you get this fluid buildup in there too. Right, so under tension, bloods form the surface, my favorite right here, liquefaction occurs, what does that mean? You're making a smoothie in there?
I don't know.
Pretty close.
Because you're just like,
Like a tissue smoothie. Yeah, it just starts to just decay, and you try to get interstitial fluid. You get a foul odor, it's caused by the bacterial action. Okay? So basically what happens, you get either infection or damage, you lose perfusion, and then what's gonna kick in later? No perfusion, no immune response, no way to stop the bacterial infection. Okay? The spread of tissue damage is rapid. Gas gangrene, on the other hand, now this can be what, now this is where people get confused. When they talk about infection or bacterial action, it could be different species of this, right?
Yeah.
Could be staph a lot of times will do it. Anything that gets in there, gets a foothold, it starts just causing massive necrosis and swelling, right? The one that we're talking about later on, called gas gangrene,
It's specific.
only caused by Clostridium perfringens. Right? And as the condition progresses, the skin may become pale and gray, make a crackling sound when pressed
Oh.
because of the gas within the tissues. Okay? Gas gangrene warrants immediate medical treatment. Without treatment, death can occur within what?
48 hours.
48 hours, no reason possible anything else. So in this case, you've got a patient, and it used to happen in war all the time because these are anaerobic spores, okay? So they get inside of a patient's leg, maybe his foot. You already lost the toes.
what's our butt?
Look, he's been hurt.
Looks like an arm.
Okay, it's an arm, whatever, but he gets shot, and spores get introduced inside of this wound. Well, what happens to the bullet wound tract?
I'm closed.
They close in behind it, you set up an anaerobic space. Now these spores germinate, as they germinate, they start producing massive amounts of gas and a toxin. And if you guys remember from micro, the damage caused by the perfringens toxin is irreversible.
Mm-hmm.
The damage is done. So it'll start to spread very quickly, and you get two things. You get a spread of the bacteria, you get a production of gas, which is gonna cause an increase in what? Fluid. A decrease in circulation because you're squeezing everything down, so it's just a what?
Gas pocket.
It's just a cascade of damage to that tissue that's bad enough. And it can be really, really nasty.
So does it start with one, or you could just start with gas? Can you progress from another type of gangrene?
No,
It's only-
for Clostridium perfringens.
That's why it's common in war, right? Like,
Right, because it's a common soil bacteria, but it's an anaerobic, so it has to have an anaerobic space. So those other ones can be aerobic. This, when it goes in there, it's like the wind track closed up behind it instead of
a breeding ground.
It's just nasty, I know.
That
Yeah,
and
when you smell gas gangrene, you know it. I've never smelled it. cellular age, holy smokes. Normal lifespan of a cell is what? Gonna be dependent on cell type, right?
Yeah.
That's intestinal cells, red blood cells, how long?
190?
Yeah, something like that. Is it skin cells or what?
Like 60, 30, 60, depends on the age.
72, yeah, it's gonna depend, I don't remember. Maybe hours, weeks, months, or years. White blood cells can be variable. Neurons may live as long as the individual, hopefully.
Yeah.
So the molecular base of aging is going to focus on mutations in gene expression. So you just start racking up mutations as you age. It's just part of aging. Just depends on what the damage is. Do all mutations lead to cancer?
No.
No. But yeah, it's very, cancer is actually pretty, I hate to say it, tough to happen. There's so many mechanisms that are designed to prevent it. Replicative senescence, what is that? Want to remember? It can be from gene damage or some cells just go into senescence, they just quit dividing.
They stop dividing?
So what's
Mhm.
senescence?
The cells just quit dividing, and they lose the capacity to divide too. Telomere shortening. Remember those little things on the end of your chromosomes?
Yeah.
You quit making telomerase, and after a while you start chopping off parts you need, right? That causes cell death. That's a major part of cell aging. Free radical energy, those ROSs I was talking about, those start damaging them. This is another major part of aging. And then you induce what?
Apoptosis.
Apoptosis.
Hepatosis.
All right. Impaired protein homeostasis. In particular, what proteins you worry about?
Which ones?
Give me a lot of your enzymes, right? Your
The
enzymes.
actin and myosin?
Yeah, not so much, but you worry about enzymes, because if your enzymes start getting damaged, metabolism starts what?
Slowly.
Getting affected, right? So now you can't metabolize it correctly.
Uh,
Defective nutrient sensing, accumulation of damaged DNA, that's back to the mutation. Okay, and then functional structural changes, alteration of organ systems. Give me some examples. We got 3 minutes.
The way that it works, or?
Yeah, what can be some of this right here?
well, like the pancreas, it stops being able to, or makes too much insulin, or doesn't make enough insulin, or
Or you can be talking about inability to produce enough synovial fluid, you start getting what? Osteoarthritis, anything, any alterations in organs, all of them are gonna start. Your kidneys start getting enough damage where they can become inefficient at filtering, right?
that's true.
And declining cell function, oxidative phosphorylation by mitochondria, synthesis of nucleic acid, transcription factors, and we just what? As we age, we do what?
Fall apart.
You just, we wear out. I mean, they hate to say it, but you do have an expiration date on the bottom of your book, you know? And that's the problem with these people who wanna live forever, right? I may be able to put telomerase back in and stay alive, but I'm gonna have horrible arthritis, I'm gonna have memory loss, I'm gonna have gastrointestinal problems, but I'm still alive, woo-hoo. So, that's one of these things I talk about living forever. All right, good.